So when we start our factoring, it kind of helps to have steps, like what is it that we need to look for? So first of all, you remember you always need to look to see if there is a greatest common factor. Can you divide everything in the polynomial by something? Number two, you want to check to see, is it a difference of perfect squares? It's important to remember it's always going to have two terms, and there always is going to be a minus sign in between them. So that's one thing to always look for. Now, just because it has two terms and a minus sign does not mean it's a difference of perfect squares, which we'll do an example like that. But that's another option. And the third thing, if nothing else works, you can use the AC grouping method. For today's lesson, you learned about the difference of perfect squares, which is one of our special cases of factoring. So a difference of perfect squares, first of all, the word difference means that we are minusing. That's where this minus sign comes from. And when something is a perfect square, that means that it's something squared. So like 9 is a perfect square because it is 3 squared. X squared is a perfect square because it is x squared. So these are just different examples of things that are in fact perfect squares. So when we factor these, like we have x squared minus 9, if we need to factor this, we'll notice it is a difference minus of perfect squares because x squared is x times x and 9 is 3 times 3. So the way this factors is we take one of each of these, 1x and 1x in each parentheses, 1, 3 and 1, 3 in each parentheses. And we put one of them with a plus sign and one of them with a minus sign. So the factorization of x squared minus 9 is x plus 3 times x minus 3. And that would be our answer. If I have to factor 4x squared, this is also a difference of perfect squares. 4 is 2 times 2, and then x squared is x times x. 25 is 5 times 5. So my parentheses would end up being 2x plus 5 and 2x minus 5. So I took 1, 2, 1x, and 1, 5 for the first parentheses. And then I also took 1, 2, 1x, and 1, 5 for the second parentheses. And the only difference is one time it's a plus sign, and one time it's a minus sign. But my final answer would be 2x plus 5 times 2x minus 5. I have 16x squared minus 81. This is also a difference of perfect squares because 16 is 4 times 4, and then x squared is x times x. 81 is 9 times 9, and y squared is y times y. So when I do my difference of perfect squares, I end up with 4x and 9y in each parentheses, 4x and 9y. One of them has a plus sign, one of them has a minus sign. So that would be my final answer. So when you look at this problem, 12x squared minus 3, notice there is a difference in there. So it is a minus sign. However, 12 and 3 are not perfect squares. But what you need to notice is that 12 and 3 are both divisible by 3. So since they're both divisible by 3, well, 12 divided by 3 is 4. So I have 4x squared minus 1. This is a difference of perfect squares. Remember, this 3 is going to come in handy later. We're going to come back to that. So 4x squared minus 1, well, that's 2 times 2 and then xx. 1 is 1 times 1, so my parentheses become 2x plus 1 and 2x minus 1. Since I had this 3 that I could divide out at the very beginning, that means everything was divisible by 3, I could factor the 3 out. I have to put a 3 in front of my parentheses, so that would be my final answer. So this problem, notice we are now factoring and solving because it equals 0. So the first thing we're going to do, our first step, remember, was to look for a GCF. Well, if I look at 14n squared minus 21n, if I break that down, or if I think about it, 14 and 21, you can divide both those by 7. If I break it down, it's easier to see that. So this is 2 times 7nn minus 3 times 7n. Equals 0. Well, there is a greatest common factor. They both have a 7 and an n in there. So I'm going to take out the 7 and the n, and I'm left with 2n minus 3 equals 0. Well, when I'm solving this, I'm looking at the first piece and setting it equal to 0. And I'm looking at the second piece, and I'm setting it equal to 0. And I'm going to solve. So 7n equals 0. To get rid of the 7 that's multiplied, I'm going to divide both sides by 7. So n equals, well, 0 divided by 7 is 0. So that's one of my answers. So for the second one, I've got to add 3 to both sides. So I end up with 2n equals 3. So I'm going to divide now both sides by 2. Divide by 2, divide by 2, n equals 3 over 2. So I'm going to end up with two answers in this problem. So n could equal 0, or n could equal 3 over 2. Either one of those is acceptable. So here I have to factor and solve. Well, the first thing I'm going to do is I'm going to look for a GCF to see if I can divide 49 and 25 by something. So I'm going to do 7 times 7, xx. 25 is 5 times 5. There is no GCF, so that's out. Step 2 is to look to see if it is a difference of perfect squares. Well, in this case, it is, because 49 was a perfect square and 29 was a perfect square. So this tells us our factorization, like most of the other problems we've had on our video, is going to be 7x plus 5 and 7x minus 5 equals 0. So I'm going to set the first part equal to 0, 7x plus 5. And then I'm going to set the second part equal to 0, 7x minus 5. And then I'm going to solve. Oops, I forgot to write equal 0 there, sorry. So I'm going to get x by itself, I'm going to minus 5 from both sides. So 7x equals negative 5. And then I'm going to divide by 7, so x equals negative 5 over 7. And that's my answer. So then I'm going to look at the next one. I've got to get x by itself, so I'm going to add 5 to both sides. So 7x equals positive 5, and then to get x completely alone, I'm going to divide both sides by 7, and I get x equals positive 5 over 7. So that's my second answer. So altogether, my answers are x equals negative 5 over 7, and x equals positive 5 over 7. And our last example, we're supposed to factor and solve 6h squared plus 17h plus 10 equals 0. So I'm going to identify first of all, I'm going to look for a GCF. Sorry, let's do that first. So step 1, I'm going to look for a GCF, see if I can divide everything by something. Well, 6 is 2 times 3, h. 17 is just 17 times h. And 10 is 2 times 5. Notice that all these were different. They didn't have anything in common, so there's no GCF. Second of all, I'm going to look to see if it's a difference of perfect squares. Well, it's not for two reasons. Number one, it's not a difference. Difference means it's going to be minused in there. There's no subtraction anywhere. Second of all, a difference of perfect squares only has two terms. So the third option is to do the AC method. And the AC method is where I need to identify A, B, and C. So A in this case is 6, B is 17, and C is 10. So then I'm going to multiply A times C, which is going to be 6 times 10, which is 60. So now I'm going to list out all of my factors of 60. Well, that would be positive 1 times positive 60, or negative 1 times negative 60. Positive 2 times positive 30, or negative 2 times negative 30, or 3 times 20, or negative 3 times negative 20. 4 times 15 would also work, or negative 4 times 15. My next set would be 5 times positive 12, or negative 5 times negative 12. And my last set is going to be 6 times 10, or negative 6 times negative 10. So remember, you can always use the calculator. You can use y equals, and you can do 60 divided by x, and go look at your table to come up with all these numbers. So now if I start finding my sums, well, I'm adding these together. So 1 plus 60 is 61. Negative 1 plus negative 60 is negative 61. 2 plus 30 is 32. Negative 2 plus negative 30 is negative 32. 3 plus 20 is 23. Negative 3 plus negative 20 is negative 23. 4 plus 15 is 19. Negative 4 plus, that should be a negative 19, sorry, or negative 15. That's going to be a negative 19. 5 plus 12 is 17. Negative 5 plus negative 12 is negative 17. 6 plus 10 is 16, and negative 6 plus negative 10 is negative 16. Well, recall that B was positive 17. So looking at my set of numbers, the only one that gave me the positive 17 was 5 and 12. So now I get to fill in my x. Well, on one side I'm going to have 5, the other side I'm going to have 12 because that's the two numbers that we came up with that were factors. So then I bring down my 6h squared, which is just going to be 6h squared. I bring this down, so it'll be plus 5x. I bring down the 12, so it'll be plus 12x. And then I bring down the 10, so it'll be plus 10. And I'm grouping these two together. I'm going to change this h to an x. It doesn't matter what the letter is as long as you have the same letter all the time. And it does equal 0. So 6, if you'll remember, is 2 times 3. There's 2 x's plus 5x. 12, if I prime factor 12, that's 6 times 2, and 6 is 2 times 3. So 12 is 2 times 3 times 2x, and 10 is 2 times 5. So then if I look for what these pieces have in common, well, out of the first two, they both have an x in there. So if I take the x out, I'm left with 2 times 3, which is 6x plus 5. Bring down my plus sign here. These two next parts both have a 2 in common, so I take that 2 out, and I'm left with 2 times 3, which is 6x plus 5, equals 0. And as before, I know I did this correctly because notice my two parentheses here are identical. So that tells me that one of my factors, one of my parentheses, is going to be 6x plus 5, and the other one is going to be x plus 2, because that was what was outside of the parentheses, equals 0. So now, for my final step, since this does equal 0, I've got to set 6x plus 5 equal to 0, and x plus 2 equal to 0, and solve. Well, I'm going to minus 5 from both sides, and I end up with 6x equals negative 5. And divide both sides by 6, and I end up with x equals negative 5 over 6 for one of my answers. The second one is much easier to solve. To get rid of the plus 2, we minus 2 from both sides, so x equals negative 2 would be my second answer.